The time complexity of an algorithm or a function is nothing but the time taken by that algorithm or function to execute. However, this computation of running time is not absolute. It is proportional to the number of statements executed inside the function for a particular input. In the same way, asymptotic space is the extra space that a function takes in RAM when the function executes. So from the beginning of the function till the end of the function, the extra space taken is the space complexity and the total time taken is the time complexity. This time and space complexity together gives us the measure of effectiveness of our algorithm. A function taking less time and a function taking less memory is better than a function taking more time and more memory. Sometimes there is a trade-off. A function is taking more time but it is taking less memory, and another function is taking more memory and it is taking less time. So there is a trade-off, and whichever resource is more dear to us, we will probably choose that function. A candidate in the interview is expected to know these trade-offs. A candidate is expected to compute the time complexity, the space complexity, and the trade-off of its own algorithm that he is providing as a solution to the problem. Interviews and real-life coding usually focuses on the upper bound. They are not concerned about the lower bound. But the GATE exam approach these concepts from a more academic point of view, where computation of the lower bound and both upper and lower bound is important. So big O notation is for the upper bound, and omega notation is for the lower bound, and theta is for a tighter bound, which is providing both upper bound and lower bound. So if you are aspiring for the GATE exam, then you should know the difference between these three and the computation of these three along with the mathematical equations and theorems. But if you are aspiring for coding interviews, then you should know how to intuitively compute the upper bound of time and space for a particular problem or for a particular code. Interviewers in a coding interview expect the candidate to come up with a thorough analysis of both time and space complexities for the code that he is writing. So whatever code you are writing during the interview, you should be capable enough to perform a thorough time and space analysis of that algorithm. In almost all the coding interviews, the candidates are expected to do a critical analysis of the solution that they are providing, and they should be able to argue why their code takes less time or why their code takes less memory or both. So they are expected to come up with a solution which is optimal both in terms of time and space. So knowing how to compute the time and space complexities is a prerequisite to coming up with the optimal solution, because how will you come up with the optimal solution if you don't know how to measure the optimality of the solution? However, the computation of time and space of a piece of code during the interview is not done using any mathematical operations like the master theorem or any such method. It is more intuitive than mathematical. In this course, first we are covering all the concepts which will help you build your understanding of time and space complexities in different situations for different piece of code for different algorithms. And then we will discuss a lot of intuitive methods to come up with the time and space complexities during the interview. We will also discuss all the mathematical methods that are used for computation of time and space in the GATE exam. So in this one course, we are covering everything from beginner till advanced related to time and space complexities. You will learn to solve the asymptotic equations that you will be requiring in the GATE exam. You will learn the recursive method, you will learn the iterative method, you will learn how to compute the time complexities using elements. You will learn how to compute the time complexities using the function call tree. You will learn how to compute the time and space complexities using the iterative method, using the recursive method, using intuitions, using substitution. So we are covering all the methods. We will also be discussing a lot of algorithms, and we will be finding the time and space complexities of those algorithms. However, we will not go in the detailed implementation of those algorithms. But we will discuss from searching to sorting, from recursion to DP, from backtracking to graph. We will discuss a lot of algorithms, and we will see how to find the time and space complexities for those algorithms. And for every concept, we have given a lot of examples from the GATE exam, and we have taken a lot of examples from real life coding interviews taken in the FANG companies, MANG companies, whatever you call it. But this course is a comprehensive one-stop solution to learn time and space complexities. Enjoy the course.